Hello everyone, welcome to our class. My name is Quotas Lee. In today's sections, we will talk about managing file systems. This is today's outline. We will talk about disk and file system structure, FAT and NTFS. Also, we will show you how to use file-based compressions, how to manage disk quota, maintain file system integrity, and defragment disks. The basic unit of storage is a disk, regardless of the partition style or disk type. Windows Server 2008 reads data from disks and writes data to disks using the disk input-output subsystems. The I/O subsystems understands the physical and logical structures of disks, which allows it to perform read and write operations. Each disk has one or more platters. Platters are the physical media from which data is read and to which data is written. The disk head travels in a circular path over the platters. This circular path is called a track. Tracks are magnetically encoded when you format a disk. Tracks that reside in the same locations on each platter forms a cylinder. For example, if a disk has 4 platters, cylinder 1 consists of track 1 from all 4 platters. Tracks are divided into sectors, and sectors represent subsections within the track and are made up of individual bytes. The number of sectors in the track depends on the disk type and the location of the track on the platter. And tracks closer to outside of the platter can have more sectors than tracks near the center of the platter. And you can format both basic volumes and dynamic volumes using FAT or NTFS. As discussed in the next sections, each file system type has a different structure, and there are advantage and disadvantage of each as well. And FAT volumes use an allocation table to store information about disk space allocations. FAT can be used with both fixed disk and removable media. For both fixed disks and removable media, FAT is available in 16-bit and 32-bit versions, which are referred to as FAT16 and FAT32. For removable media, you can also use XFAT. The advantage of using XFAT with the removable media instead of FAT is that XFAT can be used with any operating system or device. Let's suppose this file system type. And file allocation table structures and disk formatted using FAT are organized as shown in figures. They have boot sectors that stores information about disk type, starting and ending sectors, the active partitions, and the bootstrap programs that execute as a startup and boot the operating systems. This followed by a reserved areas that can be one or more sectors in length. And although FAT supports basic file and folder operations, its features are rather limited. By using FAT, you have the following capabilities. And you can use a window file sharing but have limited control over remote access to files and folders. And you can use long file name, meaning files and folders names containing up to 255 characters. And you can use FAT with floppy disks and removable disks. And you can use Unicode characters in file and folder names. And you can use upper and lowercase letters in file and folder names. However, FAT has the following disadvantage. And you can control local access to files and folders using Windows file and folders access permissions. And you can use any advanced file system features of NTFS, including compressions, encryptions, disk quotas, and remote storage. In addition, although FAT16 supports small cluster sizes, FAT32 does not. Table provides a summary of FAT16, FAT32, and XFAT. And NTFS is an extensible and recoverable file system that offers many advantages over FAT and FAT32. Because it is extensible, the file system can be extended over time with various revisions. Because it is recoverable, files formatted with NTFS can be reconstructed if they contain structural errors. Typically, restructuring NTFS files is a task performed at startup. Instead of a file allocation table, NTFS uses a relational database to store information about files. This database is called the master file table, MFT. The MFT stores file records of each file and folders on the files, and pertinent files information and details on the MFT itself. The MFT mirror stores a partial duplicate of the MFT that can be used to recover the MFT. If any of the records in the primary mirrors become corrupt or are otherwise unreadable, and there is a duplicate records in MFT mirrors. And NTFS uses the data in the MFT mirrors and, if possible, uses this data to recover the records in the primary MFT. Tables provide a comparison of key features of NTFS 4 and NTFS 5. You have the following capabilities when you use NTFS 4. And you can use advanced file and folder access permissions. And you can use a file sharing and full control remote access to files and folders. And you can use a long file names, meaning file and folder names can contain up to 255 characters. And you can use Unicode characters in files and folder names. And you can use uppercase and lowercase letters in files and folder names. And you can use NTFS with floppy disks, but can use NTFS with removable disks. By using NTFS 5, you have all the features of NTFS 4, plus additional features. And you can use encrypting file systems, EFS. And you can use sparse files, disk quotas, and object identifiers. And you can use reparse points, remote storage, and shadow copies. And you can use data streams and change journals. NTFS has many advanced features that administrators should know about and understand. These features include the following: hard links. Every file created on a Valence has a hard link. The hard link is the directory entries for the file, and it is what allows the operating system to find files within folders. Data streams. Every file created on a Valence has a data stream associated with it. Change journals. In Windows Server 2008, an NTFS Valence can use and update sequence numbers, USN, change journals. Object identifiers. Another feature of NTFS is the ability to use object identifiers. Reparse points. On NTFS Valence, a file or folders can contain a reparse point. Reparse points are file system objects with special attribute tags that are used to extend the functionalities in the I/O subsystems. And sparse files. Often scientific or other data collected through sampling is stored in large files that are primarily empty except for sparsely populated sections that contains the actual data. Transactional NTFS. Windows Server 2008 supports transactional NTFS and self-healing NTFS. File-based compressions allows you to reduce the number of bits and bytes in files so that they use less space on a disk. The Windows operating system supports two types of compressions. NTF compressions, which is a built-in feature of NTFS. The compressed zipped folders, which is an additional feature of Windows available on both FAT and NTFS Valence. Windows allows you to enable compressions when you format a Valence using NTFS. When a drive is compressed, all files and folders stored on the drive are automatically compressed when they are created. And this compression is transparent to users who can open and work with compressed files and folders, just as they do with the regular files and folders. And Windows Server 2008 also provides command line utilities for compressing and uncompressing your data. And compressed zip folders are another option for compressing files and folders. And when you compress data using this technique, you use the zip compression technology to reduce the number of bits and bytes in files and folders so that they use less space on the disk. And compressed zipped folders have several advantages over NTFS compressions. Because zip technology is an extension of the operating system rather than the file system, compressed zip folders can be used on both FAT and NTFS Valence. And zipped folders can be password protected to safeguard their contents and can be sent by email. And disk quotas are built-in features of NTFS that help you manage and limit disk space usage. And using disk quotas, you can monitor and control the amount of disk space people who access the network can use. And without quota management, it is hard to monitor the amount of space being used by individual users, and even harder to control the total amount of space they can use. And you can, in fact, do the following. Configure the disk quota system to monitor disk space usage only, allowing administrators to check disk space usage manually. Configure the disk quota system to monitor disk space usage and generate warnings when users exceed predefined usage level. Configure the disk quota system to monitor disk space usage. Generate warnings when users exceed predefined usage levels, and enforce the limits by denying disk space to users who exceed the quota limit. And by default, disk quotas are disabled. If you want to use the disk quotas, you must enable quota management for each balance on which you want to use disk quota. And you can enable disk quotas on any NTFS balance that has a drive letters or a mount point. And before you configure disk quotas, think carefully about the limit and warning label. Set values that make the most sense given the number of users who store data on the balance and the size of the balance. After you enable disk quotas, the configuration is set for and applies to all users who store data on the balance. If you want to set a specific quota limit or warning label for an administrator, and you can do this by creating a custom quota entries for that particular user account. And you can also create custom quota entries for users who have special needs, requirements, or limitations. A figure showing any existing quota entries are shown. The entries shows the following information. The status of the disk entries. Name, the display name of the user's account. And logout name, the logout name and domains, if applicable. Amount used, the amount of the disk space by the user. And quota limit. The quota limit set for the user. The warning label. The warning label set for the user. And percent used, the percentage of the disk space used toward the limit. And users are notified that they have reached the warning label or quota limit when they access the balance on which you have configured disk quotas. As an administrator, you want to check for quota violations periodically, and there are several ways you can do this. And one way is to access disk management, right-click the balance that you want to check on, and then select properties. And you can then check the current disk usage of users and see whether there are any quota violations. And you can check quota entries from the command line as well. And if you want to use the same quotas on more than one NTFS balance, And you can do this by exporting the quota entries from one variant and importing them on another variant. And when you import quota entries, if there isn't a quota entries for the users already, a quota entry will be created. If a user already has a quota entries on the variant, and you will be asked if you want to override it. As part of routine maintenance, you should periodically check disks for errors. The primary tool to do this is check disk, which is implemented in both a graphical and a command line versions. File data is stored in clusters, and the Windows operating system uses a file table to determine where a file begins and on which clusters it is stored. With FAT, the file tables used is called the root directory table. It defines the starting cluster of each file in the file systems. If a file's pointers or mapping is lost, you might not be able to access the file. FAT tries to prevent disk integrity problems by maintaining a duplicate file allocation table. They can be used to recover the primary file allocation table if it becomes corrupt. And beyond this, however, FAT doesn't do much else to ensure disk integrity. NTFS, on the other hand, has several mechanisms for preventing and correcting disk integrity problems automatically. NTFS stores a partial duplicate of the MFT, which can be used for value recovery. NTFS also stores a persistent history of all changes made to files on the variants in a log file. And the log file can be used to recover NTFS metadata file, regular data files, and folders. What these file structure recovery mechanisms all have in common is that they are automatic. And you, as an administrator, doesn't need to do anything to ensure that these disk housekeeping tasks are performed. And these mechanisms aren't perfect. However, errors can occur. The most common errors related to the following areas: internal errors in the file structures, and free space being marked as allocated, allocated space being marked as free, and partially or improperly written security descriptors, unreadable disk sectors not marked as bad. Using check disk, you can check for and correct any the common disk errors discussed previously. Check disk works on FAT, FAT32, and NTFS variants, and primarily look for inconsistency in the file systems and its related metadata. Check disk has two modes in which it can be run. It can analyze a disk, checking for errors, but not repairing them. Or it can analyze a disk and attempt to repair any errors found. And new for Windows Server 2008 is that check disk has been optimized so that it runs faster than previous versions. And you can run the graphical version of check disk by using either Windows Explorer or Disk Manager. And disk analysis for NTFS variants is performed in 3 stages. During the first stage of analysis, checkdix verifies file structures. This means checkdix examines each file's records in the MFT for consistency. During the second stage of analysis, checkdix verifies directory structure by examining directory indexes, starting with the Valence root directory index, which is stored in metadata file. Checkdix examines the index records, making sure that each index record corresponds to an actual directory on the disk, and that each file that is supposed to be in the directory is in the directory. It also checks to see whether there are files that have an MFT records but that don't actually exist in any directory. And during repair list, lost files can be recovered. During the third stage of the analysis, checkdix verifies the consistency of security descriptors for each file and directory objects on the Valence using the secure metadata file. It does this by validating that the security descriptor work. As files are created, modified, and moved, fragmentation can occur both within the Valence or location table and on the Valence itself. Windows Server 2008 provides tools for defragmenting Valence called the disk defragmenter. To reduce fragmentations, Windows Server 2008 can manually or automatically defragment disks periodically using disk defragmenter. The more frequently data is updated on drives, the more often you should run this tool. Windows Vista within SP1 or later and Windows Server 2008 automatically perform secret pickup defragmentations. With these features, when a scheduled defragmentation path is stopped and returned, the computer automatically picks up the next unfinished Valence in line to be defragmented. And using disk defragmenter, you can check for the correct Valence fragmentation problems on FAT, FAT32, and NTFS Valence. The areas checked for fragmentation include the Valence files, folders, the page files if one exists on the Valence, and the MFT. And being able to check the MFT is a new feature for Windows Server 2008. Another new feature is the ability to defragment Valence with cluster size greater than 4K bytes. And understanding the fragmentation analysis, the summary of the Valence configurations and space usage reports on the following areas. File fragmentation gives an overview of file level fragmentation, showing the percentage of used space that is fragmented. The total number of files on the Valence that are movable. The average size of those files, how many files are fragmented, the total number of exist fragments, the average number of fragments per file, and the total number of unmovable files. Free space fragmentations gives an overview of fragmentation on the Valence unused space, showing how much free space is available on the Valence, the number of extents on which free space is located, the average free space per extent, and the largest free space extent. And folder fragmentations gives an overview of folder label fragmentation, showing the total number of folders on the variance and how many folders are fragmented, and master file table fragmentations. For NTFS variance only, gives an overview of fragmentation in the MFT, showing the current size of the MFT, the number of records it contains, the percentage of the MFT in use, and the total number of fragments in the MFT. If you run defrag again without the -A parameters, the disk defragmenters will set about cleaning up the drive to give optimal space usage.